The universe is absolutely massive. Some things are so large, it's just impossible to comprehend their size. And on the other hand, some things are so small, it's impossible to comprehend how small they are. Let me show you what I mean. Consider one of the smallest things the naked eye can see, a grain of sand. Now, sand particles vary in size between about a 1/16 of a millimeter and 2 millimeters. Now, imagine we take a very small grain of sand, just a 1/10 of a millimeter wide, and expand it so it's as tall as the Empire State Building, 1,453 feet high. At this incredibly magnified scale, a single skin cell would measure over 430 feet high. A red blood cell would be about 100 feet high. Bacteria are even smaller, with E. coli measuring about 30 feet and Salmonella measuring about 16 feet. Viruses are smaller still, with the smallpox virus measuring about 4.6 feet high, and the hepatitis B virus would be just 7.5 inches wide. Think about that. If a grain of sand were as tall as the Empire State Building, a hepatitis B virus would only be this big. But things get smaller still. The hemoglobin protein inside our cells would measure just under an inch. Smaller than that, a molecule of glucose would be just half a centimeter long. The largest atom, a cesium atom, would be 2.3 millimeters wide, and the smallest atom, a hydrogen atom, would be just half a millimeter wide. But what if we wanted to go even smaller? Well, every atom is comprised of protons, neutrons, and electrons. The protons and neutrons are bound in the center, and the electrons whiz around them. The hydrogen atom, being the simplest atom, has one proton in the center and one electron orbiting it. You might be familiar with a model like this, but this is in no way to scale. To put it to scale, let's first expand this atom up to the size of a baseball stadium. At this level, our brains simply can't understand what these sizes even mean. At this scale, that original grain of sand would fill up a space 435 times that of Earth. Think about that, a grain of sand expanded to half the size of Saturn. So if we take this baseball stadium to be the size of a hydrogen atom, how big would that proton in the center be? Well, about the size of a grain of sand, less than a millimeter wide. That's right, if a hydrogen atom were a baseball stadium, the proton in the center would be a grain of sand. So what's in all that empty space between the proton and electron? Nothing. A hydrogen atom is 99.99999999996% empty space. And because everything is made of atoms, including you, that means you are this much empty space. But it doesn't end at protons. Protons themselves are made up of smaller particles called quarks. Now, to visualize the size of a quark, we'll first have to expand this grain of sand proton up to the size of this pumpkin. And at this scale, we could find that a quark would be about 4 millimeters wide, or about half the size of this pea. So to recap, first we took a grain of sand, just a 1/10 of a millimeter wide, and expanded it to be as tall as the Empire State Building. At that scale, we found a hydrogen atom to be just half a millimeter wide. We expanded that half a millimeter wide hydrogen atom up to the size of a baseball stadium. And at that scale, we found the proton in the center to be just the size of a grain of sand. We took that grain of sand proton and expanded it to the size of a pumpkin. And we found that a quark, the building block of a proton, would be just half the size of this pea. Quarks are the smallest particles that we know of, but what if we want to examine the opposite end of the spectrum, the massive? Let's start with the most you can see at once. On completely flat ground, depending on your height, the average person can see about 2.8 miles in any direction. But topography can change this drastically, so how much can you actually see at once? This is Catalina Island. It's about 22 miles long, and the Trans-Catalina hiking trail that winds through it is about 37 miles long. And it takes about 4 days to backpack across. It's a bit hard to see with the haze, but everything behind me stretches about 40 miles long. The state of Mississippi or the country of Belgium both are about 170 miles long, which is a little more than 4 times the length of what we can see from here. The United States is about 2,800 miles long, about 16 times longer than Belgium or Mississippi. And driving in a straight line at a constant 60 miles per hour, it would take you about 2 full days to cross the US. Now, the US has an area of about 3.8 million square miles. It's roughly the same as Europe, but Asia beats that by being 4.5 times larger, and the Earth itself is another 11 times the size of Asia. And if the Earth were shrunken down to the size of this globe, everything we can see from the top of this hill would fit into a space less than a millimeter wide. And at this scale, the sun would be about as tall as this building, 93 feet tall. If you could drive around the sun traveling at 60 miles per hour, it would take you over 5 years of constant driving. Now, Polaris, the North Star, would stand nearly a mile tall at this scale. Think about that. The Earth just 10 inches and Polaris a mile. Now, the largest star currently known is VY Canis Majoris, and that would be a ball 25 miles tall. For reference, Everest is about 5.5 miles tall, and commercial airplanes fly about 8 miles above the ground. But let's scale this down even further and say that the Earth is the size of a grain of sand. Well, at that scale, the sun would be about the size of a marble placed nearly 4 feet away from Earth. Pluto would be about 100 feet away at its closest approach, and our entire solar system would stretch about 1.4 miles long. The nearest visible star, Alpha Centauri A, would be the size of another marble, but placed 200 miles away. This just goes to show how spread apart the universe is. Hundreds of miles separating two marble-sized stars. But the Milky Way contains somewhere between 1 and 400 billion stars, and the Milky Way is about 100,000 light years across, which means that it takes light about 100,000 years to cross it. And at this scale, with the Earth the size of a grain of sand, the Milky Way would stretch from here to the Moon, and then another 19 times further. If the Earth were the size of a grain of sand, the Milky Way would measure 5 million miles across. But the Milky Way is part of what is called the Laniakea supercluster, a group of about 100,000 galaxies. Now, to visualize the Laniakea supercluster, let's first shrink down the scale even more and say that the Milky Way is the size of a tennis ball. At this scale, the Earth would be the width of a proton, which you already learned how incredibly tiny protons are. Our brains simply can't understand this scale. I mean, the entire Earth has been compressed into a single proton. And at this unimaginable scale, the Laniakea supercluster would stretch about 1,000 feet long, or about the distance from here to that jetty. The observable universe, everything in the universe we can see, would be 37 miles long. And 37 miles is about the length of the Trans-Catalina Trail that winds through Catalina Island. And if you remember from earlier, it takes about 4 days to backpack across. So if you consider that trail to be the length of the observable universe, then the Earth would be a single proton somewhere in the mix, just a millionth of a billionth of a meter wide. But scientists speculate that the entire extent of our universe is at least 250 times longer than the observable universe, and it might be even larger than that. We humans are only capable of visualizing a narrow window of sizes, and we're often blind to the true scale of the universe we live in. Compared to the subatomic level, you are massive, so incredibly large. But compared to the universe, you are nothing, so incredibly small.